we have here the x-axis, and this here is going to be the y-axis. We are going to be sketching the graph of y is equal to modulus of x, which means that this part of the graph, according to what we have learned, this part of the graph will remain the same. This part of the graph will disappear, and whatever that is on the positive x-axis side of the graph is going to be reflected about the y-axis and duplicated on the negative x-axis part. So on the positive side of the x-axis, we have a vertical asymptote and we have this oblique asymptote. For this horizontal asymptote, it is the behavior of y when x tends to minus infinity, which means that the horizontal asymptote shouldn't be reappearing in my new graph. So let me sketch in the two asymptotes first. For my vertical asymptote, we have it here. So this here is x is equal to 4. So we have x is equal to 4 as my vertical asymptote, and this vertical asymptote will also be reflected about the y-axis. So let me just sketch in the reflected asymptote. So we have that here. Okay, and this is x is equal to minus 4. Let me sketch in the oblique asymptote. So my oblique asymptote is going to be something like this. Okay, this will be my oblique asymptote. And this is y is equal to 10 minus x. And it is going to be reflected about the y-axis. So geometrically, it is going to look something like this. We need to label this oblique asymptote. So for this oblique asymptote here, it is going to be a reflection of the original oblique asymptote about the y-axis. So x is going to be replaced by minus x, which means that for this, we are going to have a y is equal to 10 minus, where x is going to be replaced by minus x. So we will have a 10 plus x. So this will be my labeling for the oblique asymptote. So we have a y is equal to 10 plus x. And if I were to duplicate this part, we will have something that is like this. So at the same horizontal level as this intersection here, we will have where the graph is going to be intersecting the y-axis, the y-intercept. And I'm going to draw it such that it is going to be tending towards the asymptote, and when it comes down towards the y-axis, it is coming down at an angle. So when it is being reflected, we will have a sharp point as the new y-intercept. So we have something that is like this. Okay, and here is going to be a sharp point, and the coordinates of this point is going to be at 0, 6. It is the same as this. And we are going to be replicating this part here. So we have our graph touching the point 6, 0, and then tending towards the oblique asymptote. So my graph is going to be something like this. Okay, tending towards the oblique asymptote, and this point here will be 6, 0. And this is going to be reflected about the y-axis. So we have another part of the graph here. So you will touch here on the x-axis, and you tend towards the vertical asymptote. So we have it here. And the coordinate of this is going to be minus 6, 0. So this is the graph of y is equal to f modulus of x. For this graph, y is equal to 1 over fx. I'm going to make use of the sequence of consideration that I've discussed on the Achevas TV. So the first thing that we want to consider are all the asymptotes. Vertical asymptote x is equal to 4 will become a x-intercept. So it's going to become a point that's going to be on the x-axis, and x is equal to 4 will become 4, 0. And for the horizontal asymptote, y is equal to 6 will become a new horizontal asymptote, y is equal to 1 over 6. So let me draw in this horizontal asymptote. Let's say it is here. So labeling this, y is equal to 1 over 6. An oblique asymptote is seldom discussed, so if I were to try to do the analysis for this oblique asymptote, we can see that it is trying to describe for us the behavior of y when x tends to positive infinity. So to analyze this, I'm going to create for myself an arbitrary point that is here. I'm going to transform this point. So assigning to this arbitrary point an arbitrary coordinate, it can be, for example, 100 and minus 100, because the x coordinate of this point is pretty big, so I'm going to go for 100. The y coordinate of this is pretty negative, so I'm going to go for negative 100. Going through the transformation of 1 over fx, it is going to become a point 100. The x coordinate remain the same, but the new y coordinate is going to be 1 over this, so it's going to be negative 0.01. So plotting this point here, it is going to be a point that is very close to the x-axis, which means that all these points here will be very close to the x-axis but not touching the x-axis. This gives me a horizontal asymptote y is equal to 0. So that will take care of the oblique asymptote. Next, we're going to move on from asymptotes to all the x, y intercept. We have two of them. One is here, the other one is here. So for this, when x is equal to 0, y is equal to 6. So when x is equal to 0, y is equal to 1 over 6. So I'm going to continue to get a point that is on the horizontal asymptote, y is equal to 1 over 6. So it's going to pass through this point, and this point will have a coordinate of 6 and 1 over 6. And for the x-intercept, it is going to become a vertical asymptote. So it is going to become a x is equal to 6 as the vertical asymptote. So let me sketch it in here, the vertical asymptote. So let's say it is this. Okay, so we have a vertical asymptote, x is equal to 6. And then we are going to do our analysis from the left to the right. All the way to the left, it is a point that is very, very close to the horizontal asymptote. If I were to assign an arbitrary coordinate to this point can have a coordinate of, let's say, minus 100 and a value that is slightly smaller than 6. So for example, 5.9, which means that it is going to be transformed to minus 100 and 1 over 5.9. And 1 over 5.9 is bigger than 1 over 6. So we get a point that is slightly above 1 over 6. And it's going to go to this point, minus 3, 5. And as this point undergoes the transformation of 1 over fx, this point will become minus 3 and 1 over 5. So it's going to become a point that is above 1 over 6 because 1 over 5 is bigger than 1 over 6. So let's say it is going to be a point that is, say, here. Okay, so we have a minus 3 and 1 over 5. Let's connect the points together. So it is going to be this, exhibiting the behavior of the horizontal asymptote, y is equal to 1 over 6, making a turning point here, then joining this point and here, and then you will continue towards x is equal to 6. Let's join the points first. So from here, it is going to be joined to this point here. Then from here, it is going to be joined here. And as it goes nearer and nearer to x is equal to 6, if we are unsure, we can try the same thing. I will assign an arbitrary coordinate to a point that is very close to x is equal to 6. So let's say the coordinates of this point is, let's say it's very close to 6, right? So let's say 5.9. And we can see that the y coordinate is going to be very, very close to the x-axis. So let's say negative 0.01. So as it undergoes transformation, it will become 5.9 and minus 100. Okay, 5.9 and minus 100 will be something that is like, this is 6, 5.9 will be slightly to the left, and minus 100 will be all the way at the bottom here. So now joining the points, we know that the graph is going to tend towards the negative portion instead of going back up towards the positive portion. I can try the same thing here towards the right hand side of 6. So for this point here, let's say we give it an arbitrary coordinate again. So let's say we are going to go for a 6.1 and negative 0.01. So as it undergoes the transformation, it will be 6.1 and negative 100. So 6.1 and negative 100 is going to be somewhere here. And this point is going to be joined towards this point. And this is going to be exhibiting the behavior of a horizontal asymptote y is equal to 0. So to complete my graph, it's going to look something like this. Okay, and it should tend towards the horizontal asymptote y is equal to 0.